Hello, everyone. Welcome to episode 11 of the Learn System Design podcast with your host, me, Ben Kitchell. This week, we are going to be continuing down that primer of building a system and the sort of things you want to gather before even drawing your first box in that design aspect. These episodes are a little more geared towards your system design interview. With like tech companies, most tech companies have a system design interview portion. But if you're going to be building a system at all, these are still very relevant. These are still steps that I take that, I've collected throughout the years and found online and things like that. So I think this is also going to be helpful for you as well. If you haven't yet, I do recommend listening to the previous episodes, at least episode number 8, which is the beginning of the primer, to sort of get a retrospective on how we've gotten to this choice and how we're here, and also to sort of look back and we'll be touching on, again, functional, non-functional requirements, API models, things like that we've talked in the last episodes, and I'll be referencing those. And so that'll be important for understanding this episode as well. Without further ado, let's get into this week's topic. Database models. What are they? Who are they? Where do they come from? The truth is they come in all shapes and sizes, and we're only going to be covering what I feel are a few key models today. And we'll be talking about the general pros and cons of using each model. Again, some companies might even just ask you to design a database model and nothing else, depending on the position that you're applying for, or what you'll be working on. And because, as you will remember from the early episodes, there is no one size fits all to when it comes to designing an efficient system. Put simply, a database model is a rough representation to what your data looks like and how it's stored in your system. And you want to think about how it's stored because you're going to be accessing it or writing to it a lot, and you want to make sure that you take those things into consideration. Jumping right in, the first model we'll talk about today is probably going to sound a little familiar. It's the relational data model. And as you might have guessed by the name, the relational data model is a direct representation of relational databases. If none of this is sounding familiar to you, I recommend going back and listening to the first few episodes of this podcast. Just a little plug, I re-recorded, remastered the first episode, so the loud music is gone. Thank you for everyone who wrote in about that. But the first few episodes are up, and they specifically dive into databases and relational databases as well, and where we talk about the strengths and weaknesses of each kind and why you would want to use one versus the other. Now, the relational data model is usually represented by like a 2D matrix of rows and columns. If those words sounded like gibberish to you, just imagine like a smaller version of like Microsoft Excel. Each table in your database is just represented by one of these squares with some rows and some columns, and that's simply known as like a relation. And for each row in the table, you'll define specific attributes that will serve as identifying keys for your data. For example, if you have like a user table, you might have an attribute called user ID. That's a unique signifier for the user. You might also have an attribute called email, which would be populated with the user's email address. These attributes can also have rough signifiers when drawn out to show how they relate to each other. If you recall, relational databases have what are known as primary keys and foreign keys, where primary keys are these special attributes that are unique to a specific row. For instance, the user ID usually is a good primary key for the user table because generally it's going to be unique, and it'll be unique to not only the row, but all the other rows as well. And the foreign key is basically a key that references another table. If you again imagine a user table and then also maybe an address table, the address table might have an address with attributes like city, street, etc., right? But it also would have maybe a user ID attribute. And this user ID attribute would reference the user ID in the user table. That connection, that user ID in the address table, that's a foreign key. And now the way you relate this on, draw.io or on a whiteboard in an interview or however you might be drawing this up, usually people depict it with an arrow drawn from the user ID in the address table to the user table. So it's just an arrow, but you can use whatever signifier you'd like as long as you make it clear this is what I'm making, the reference for the foreign key. The important part is to just be consistent. If you draw a foreign key with a circle and a circle, just make sure you do all of your foreign keys like that. If you use an arrow, that's the most common one that I've seen. Just call it out and consistently use the arrows for foreign keys. Relational data models are the most common models you'll see when designing systems. They're simple to draw. They're very flexible by design. When it comes to migrating your DB model to your API model, it can almost be a one-to-one change for the most part, saving you a lot of time in these interviews. However, it's important to consider that relational data models only fit for relational databases and the like. It should also be mentioned that the larger your model becomes, the harder it can be to sort of track these relations and all this different data and how they're related to one another. The next model is the Entity Relationship Diagram, or ERD. Some of you who've taken a database class or have worked with star schemas might have just had your ears perk up a bit. These are pretty common, especially when it comes to database classes in university. But ERDs are great when you want to show roughly how your data relates to each other in more of a real world sense rather than a direct relation sense like you would with the last model. It helps to visualize the data for a non-technical audience when trying to design your system. Whereas like a relational model is very technical and easy for an engineer to understand, an ERD model might be better for someone who doesn't have a technical background, maybe like a sales pitch or, an MVP for like your CEO, things like that. ERDs are also shaped a little differently. If you picture in your mind like just a single box, and we'll call that the employee box. And then we can have another box called department, right? The employee box might look sort of like an octopus. It has a bunch of lines coming off of it with a bunch of, bubbles attached. And those bubbles are just sort of like the attributes that we talked about before. It might have like an employee ID. The other might have like a name. The department would also have a bunch of bubbles, have like department ID and maybe like a city for its location, right? So it's these two separate things in space, a box being your main thing, and then little bubbles connected to it that are the sort of attributes. Technically, entity relationship diagrams don't really have attributes. I'm just using that to give you an idea to tie it back to the relational data model. The main difference, though, is you can show how these things relate to each other in a more real-world sense, rather than just, if we're thinking about this in a relational data model where the department ID would be in the employee ID table as a foreign key. Instead, and we would have like an arrow that's drawn from like one little attribute to the other attribute to signify a foreign key, right? Well, with an ERD, you actually get to explain in a real world sense how they relate to each other. So we can add a line from the employee to the department, and then in the middle have a shape, usually like a diamond or a circle. Doesn't matter. Just, again, consistency. And the label will actually show the relationship. So for an employee in a department, we might have a diamond in the middle that says works in. So every employee works in a department. And furthermore, we can also relate these relationships for how they actually apply to each other. For instance, a department might have many employees, but an employee would only have one department, right? So that's a many to one relationship. If we had a user credential like we did in the last one that stored like the email and the password, and that email and password is some sort of credentials table, and then you have the user table, then that would be a one-to-one, right? Like every employee has one set of credentials. And finally, to round it off, it's the many-to-many relationship. We might have a projects entity where many employees have worked on many projects, and many projects have many employees that have worked on them. So again, you can signify these by just writing an M or an O for many or one beside all of the entities, and you can sort of show how these relate to each other, right? And one of the biggest benefits of the ERD models is what I mentioned before. They're great at showing real world relationships, especially for people who are not as technical. Now, if you handed me an ERD model and said, okay, build a database, it might be a little bit more difficult than if you handed me a relational data model, right? But instead, it allows me to talk to my non-technical manager in some way and say, hey, here's how the data flows to me. We can build what's called the domain-driven design and understand how our data flows through our system, how it'll be used by our users, and we can design our data flows based on that. So because it's so great for non-technical people, the problem, of course, is that it's not so easily interpreted by people when it comes to actually implementing this design for the data to be structured. The last model we'll be talking about is actually called the network data model. Some of you savvy listeners who might already be familiar with data models might already know that this is just an improvement on the hierarchical model. And I don't really want to touch on the hierarchical model just because I feel like the network model just builds on it so much. And the hierarchical model, honestly, besides being hard to say, is also kind of common, right? Like when you think of a hierarchy, you can sort of picture in your head this pyramid structure. But the network model takes a more graph-like approach, using childs and nodes to better show a more complex relationship. Unlike the hierarchical model, which can only have like a single parent and child nodes, the network model actually allows you to have multiple children or multiple parents, which allows for many-to-many and many-to-one relationships entirely, whereas the hierarchical model just doesn't have the ability to show these at all. If you've ever seen a hierarchical model or even a graph representation or basically any sort of tree, then you can sort of get a good idea of what it looks like. It's just a tree structure. It just has circles. They represent some sort of entity. And other circles at different levels below them usually, connected via arrows to show a relationship. A good way of visualizing this is sort of like thinking about a restaurant. At the top of the restaurant, you could have one or two or multiple owners, right? But they're the top. They, are the big bosses, right? Underneath them, you might have like a few senior managers, and under them, a few managers. And then the last line, you might have like a few employees who report to those managers, right? And sort of creates this tree-like structure where the first level's the owners, the senior managers, the managers, then, the employees, right? And you can see how the managers and the employees and the owners all have this parent-child relationship where one manager might have multiple employees or it might just have one. But the designation level in the tree is a category within itself. And the biggest benefit of this sort of structure is just that it's inherently hierarchical. If your data is sort of complex, it has a lot of one-to-many or many-to-many relationships, it's great to show and have those different levels to sort of decipher how things actually look and how these relationships, especially when it comes to like a power dynamic or something like that, can be structured out. But the biggest drawback, honestly, is just using it in the wrong instance. If you don't have a lot of data that it should be hierarchical, or have this sort of, like I said, level dynamic, then you're just going to have something that is completely complex and hard to understand. If you imagine something where, like a user and their address, like we talked about before, and you try and structure it like this, you're just going to have a bunch of circles in a straight line all connected to each other in the same category or same level, right? And that's completely hard to understand and read. Regardless of the type of model you choose, there are a few steps you should always consider. The first is just identify your entities. These are the unique things in your design that help to describe the concepts or events or whatever the main part of your design is, especially when it comes to your data. For instance, you're designing Spotify. We talked about this in the last episode, right? And one of those core functional requirements would probably be users should be able to play a song, right? What would you think would be the entities to come from the sentence, users should be able to play a song? For the first, it's a user, right? User should be able to do something, right? So that's your first entity, a user. And of course, the other would be a song. You need to take an action upon a song. And the user entity would probably have something like an ID, email, password, etc. Then the song would have like a song ID, the number of plays, and an album ID, right? Like these sorts of things. Already, we've started to plan out our entities before we've even thought about having a model. And that's the next step. It's identifying the key properties that belong to these entities. Or as I've said before, they're just the attributes, right? From here, we can move on to how the entities relate to each other, if they relate to each other. Are they related based on their properties? Is it more of a hierarchical structure? This is where the model choice actually comes into play.
Stay with us. We'll be right back.
Ready to plug into the future? Join myself, Sean Leahy,
and me, Andrew Maynard,
on Modem Futura, where we explore the technologies shaping our futures.
We bring the experts, the insights, and a whole lot of curiosity to every episode of Modem Futura as we boldly go where no one else has gone.
So join us as we navigate the intersection of innovation and humanity, uncovering the stories that will define our collective futures. Subscribe to Modem Futura wherever you get your podcasts.
We'll see you there.
See you then.
Next, you'll actually choose the model, how they relate, of course, formally deciding and roughly making a sketch of how the model applies. Draw some tables, draw an ERD diagram, maybe draw a tree, whatever best fits your approach and where you're going with this. But the key is you now have those base entities formed already. You already have a good idea of what the entity will be and a couple of the attributes. You don't have to have everything at this point. I want to say this again to make sure it sinks in. The DB model planning phase, you don't need to plan every single attribute that you're going to have. And I'll talk about that more in a few minutes. But for now, it's just having a loose idea, getting a loose sketch of how these are related, get it down on paper, show that you're thinking about the entity and thinking about all the attributes on that entity. From here, you can start to add a little bit more important attributes as they sort of form, right? I always like to have at least an ID, a date created field, and an is deleted field, no matter what. So if we're doing an email table, I'm still having an email ID, a date created, and an is deleted field, no matter what. And then after you flesh those out, you can start to think about some of those specifics to the entity, or create other entities to map to it, right? Like what would a user on Spotify have that a user on Instagram doesn't have? Again, you do not have to have everything right away, but just flesh it out, the things that you can think about, and just don't spend too much time, right? I'm not worried about whether or not you can think of 50 attributes for an entity. Instead, what I want you to focus on is the core things that make this entity what it is. And the more you have it fleshed out, the more you understand, the more you can relate it to your API model. If you've already done your API model, great, then you'll probably have a better base understanding for what you need in your database model. If you haven't fleshed out your API model, then you can just have a nice structure formed, go to the API model, and come back and build up your DB model while you're building up the API. You might realize when you're creating a route for your API that, I forgot this field, right? So just add it to your DB model. No big deal. You don't have to spend a whole bunch of extra time trying to, create something out of thin air in the API model. And instead of building out your API with like a bunch of params, you can simply say, we have a user and a song entity, right? So the user might call play song, and the user ID is already authenticated, so we don't even need that in the call. We just need the song ID or the song, the song ID to come in, and then the response is just the song model. So you don't have to send back, it'll come with the song ID and it'll come with an album ID and like all these things. Like, no, I'm just going to send back a song, and you can reference your DB model, and that's what it's getting sent back. Time saved, right? And it's perfectly fine to work on the API model first or the DB model. I like to sort of bounce back and forth, right? Because you're going to forget things, especially if you're in an interview, and you can just sort of build them up together. That's why I consider these two episodes, the one before this one and this one, to sort of be partner episodes. And I mentioned in that last episode that you might do your DB model first, you might do your API model first, but the most important thing is just that they work together, that they make your life easier by having these models and these routes use the models accordingly. In the end, data models are less about designing a full database, and instead they're more about showing you are taking the data into consideration and you understand how the data and its entities will relate to one another. After finishing your DB model, you can see a form growing of what kind of database you need to rely on. If you have a lot of relational data from a technical side, right, then pretty obviously you can grab a relational database. If you find your data is more structured like a network model, maybe it's time to pick up a NoSQL or a graph database and start working with those. And again, as I've mentioned before, depending on the data, sometimes it's okay to have different databases for different uses, depending how complex the system is. I would caution against starting off with 3 types of databases and maybe build to that aspect. But we'll talk about that more next on the next episode, which will actually be the wrapping up of the interview primer, right? Next episode, we're going to talk about how you draw out these diagrams, how you go from point A to point B, fleshing out these diagrams either on a whiteboard or a website, when you're on like an interview or on a sheet of paper, whatever is the easiest for you. Ultimately, this is just another way of me saying, know your data, know how it flows through your system. It's paramount to building it. Showing knowledge of this one thing can be one of the biggest tips I can give you when it comes to designing a system. As I mentioned before, next episode is actually going to be wrapping up this interview primer, as it were. We're going to be talking about drawing the diagrams and things like that. After that, we're going to jump into our first episode of practicing real-world examples, actual system design examples you might get in an interview, how I would approach it, but, giving you tips and giving you ideas about how to approach these things. That episode specifically will be focused on building out a web crawler and the design behind building out a system for that. So I hope you stick with me. I hope you're enjoying it. I want to thank everyone who reached out. Leah Whitelaw, you've sent a few emails back and forth. I hope everything has been going well with your interviews. Again, you helped influence the last episode where we talked about Spotify and these sorts of things. So hopefully that's been great. Thank you for all the amazing fan mail, everyone in the Discord. Big shout out to Roman, Torres, Gamesply, Beerax. You guys are killing it over on the Discord, and I very much appreciate it. Big thank you to Tom for the discussion and honestly just being amazing on the Discord as well. I also want to give a huge thanks to all my Patreon supporters. Leah Whitelaw again, thank you. Lucas Anderson, Kaylin DeSica, Sergey Bergera, Anil Dugar, Jake Mooney, Charles Cazals, Eduardo Muth Martinez, Waro Soares, Adrian Kurek, Gabriel, Jesper Klotzel, Nathaniel Sutton, Florian Breiter, and Clavian S. You guys are all amazing and helping me out on that Patreon. Thank you also again for voting on that poll where we're going to be talking about the web crawler. That will be coming in the 2 episodes from now. And then I'm hoping to also get an episode out very soon. I'm about halfway done with writing it for the actual authorization special episode for you guys. So be on the lookout for that. And then if you would like to suggest new topics, be a guest on the podcast, feel free to drop me an email at learnsystemdesignpod@gmail.com. Remember to include your name if you'd like a shout out. If you'd like to support this podcast, help me pay my bills, please jump over to our Patreon, consider becoming a member. All podcasts are inspired by Crystal Rose. All music is written and performed by the wonderful Aimless Orbiter. You can also check out more of his music at soundcloud.com/aimlessorbitermusic. And with all that being said, this is Ben. I'm scaling down.